Hello, sixth graders, and welcome to Lesson 5 in Chapter 4. Today we'll be discussing equivalent fractions. Okay, so let's start by defining a few vocabulary words. Our first one is equivalent fractions, and equivalent fractions are fractions that represent the same value. Okay, I always like to give a pizza example when I'm talking about fractions. And let's say I have two pizzas, and one pizza is cut in half, and the other pizza is cut into fourths. Okay, and in the first pizza, I eat half of it. So there are two total pieces, and I eat one of those pieces. And in the second, there are four total pieces, and I eat two of those pieces. Well, you can kind of see by the shading here that even though these are two different denominators and they're two different fractions, they represent the same value. I'm eating the same amount of pizza. Okay, that's the way I like to think about equivalent fractions. And next, our second vocab word is simplest form. So that is a fraction in which the greatest common factor of the numerator and denominator is 1. Okay. And I think a lot of you have a good idea of what simplest form is. Let me give an example. Let's say that we had the fraction 6/8 and we wanted it in simplest form. Well, right now, they have a common factor, each of these do, of 2. So I could divide each of these, the numerator and the denominator, by 2. And that would give me 3/4. And now this would be considered in simplest form because the greatest common factor of 3 and 4, well, the factors of 3 are 1 times 3, and the factors of 4 are 1, 2, and 4. So their greatest common factor is 1. Now it's in simplest form. Okay, let's take a look at our first example. Looks like we're going to be using some blocks here or some models to represent equivalent fractions. It says find two equivalent fractions for 10/12. So you'll see here there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. That's where they get the denominator 12. And 10 of them are shaded. 2, 4, 6, 8, 10. Okay. What is this model representing? Well, looks like we have 1, 2, 3, 4, 5, 6 rows of 1, 2, 3. So 6 times 3 would give me 18 total blocks. And how many of those are shaded? 1, 2, 3, 4, 5 times 1, 2, 3 would give me 15. And you can see the shaded amount is the same. So 10/12 is equivalent to 15/18. And it's also equivalent to 1, 2, 3, 4, 5, 6. There's 6 total here. And 1, 2, 3, 4, 5 of them are shaded. So in other words, 10/12 and 15/18 and 5/6 are all equivalent fractions. Right? Again, I just got that by counting the number of shaded to the total number. Let's take a look at an example where we don't have where we don't have a model. Let me bring up my screen sketch here. And it says, find the missing number that makes the fractions equivalent. Okay. And the way I'm going to tackle this is looking at my two ratios. So I have 3 to 5 is equivalent to something over 20. And the question I'm going to ask myself is, how did I get from one to the other? Okay, so in the denominator, 5 is multiplied by what to get 20? Well, that would be 4 to get 20. Okay, so I multiply by 4 on bottom. If I want to keep these ratios or these fractions equivalent, I also need to multiply by 4 on top. So I need to take 3 times 4 to find my missing numerator. And again, that's the same thing. What I showed here is the same thing they're showing here, multiplying by 4 on top and bottom. So multiply the numerator 3, that was our numerator originally, by the same number 4. Okay, and that will give us an answer of 12/20. So 3/5 is equivalent to 12/20, right? Go ahead and flip over, and we'll try letter B. Kind of similar now, except we're missing the denominator to start with. So it says, find the missing number that makes the fractions equivalent, right? Again, in the numerator, 4 is being multiplied by what to get 80? 4 times 2 is 8, add a 0, so 4 times 20, multiplying by 20 on top. So on the bottom, I would need to do the same, multiply by 20. Okay. Multiply the denominator 5 by the same number 20. Multiplying by 20 on top, that would give me 80, and multiplying by 20 on bottom would give me 100. So 4/5 is equivalent to 80/100. All right. Hopefully you're starting to pick up on the pattern there. Let's move to example 3. And it says to write the fraction in simplest form, and we have 20/48. So the best way, the quickest way to get a fraction in simplest form is to divide by the greatest common factor. Okay, so what is the greatest common factor of 20 and 48? Well, remember, you can always list your factors. So you could say 1 times 20, 2 times 10, 4 times 5. And you could do the same for 48, listing the factors of 48. 1 times 48, 2 times 24, so on and so forth until you work your way to the middle. Let's see, 4 times 12, and so on and so forth. 6 times 8. And the greatest of these that they have in common is 4. Okay? So you see it says, so it's not in simplest form. Remember, if it was in simplest form, 1 would be the greatest common factor. So we're going to divide each of them by 4. 20 divided by 4 would give me 5. And 48 divided by 4 would give me 12. Okay. Divide 20 and 48 by their greatest common factor, 4. Exactly what we did right here. All right, so 5/12 would be our answer. Letter B is 7/10. Okay, the greatest common factor of 7 and 10 is, well, the only factors of 7 are 1 and 7. 1 times 7 is 7, and that's it. So the greatest common factor of these is actually 1. So 7/10 is already in simplest form. Nothing we have to do there. Fantastic. We're going to end with the check it out section. Please now pause the video and try 1 and 2 on your own. Okay, it wants 2 equivalent fractions for 4/6. So one way that we could do this is to simplify or divide by a common factor for each of these, or you can make it bigger, and I think the easiest way to do it is just multiply by 2 to get a equivalent fraction, like I did for the pizza example. Okay, so 4/6, we could simplify that by dividing the top and the bottom by 2. So 4 divided by 2 would be 2, and 6 divided by 2 would be 3. So 2/3 would be 1. I could also multiply both by 2. So 4 times 2 would give me 8, and 6 times 2 would give me 12. These are probably the easiest two. Now, there's a ton of different equivalent fractions. I could multiply the top and bottom by 3, so I could get 12 over 6 times 3 would be 18 would work. Yeah, you could keep going. There's so many different equivalent fractions, probably infinite actually, that you could keep going and going and going with. But again, I think it's just easiest to simplify and to multiply by 2. And lastly, the missing number that makes the fraction equivalent. Well, how did I go from 9 to 27? Well, I multiplied by 3. So I'll multiply by 3 on top. 3 times 3 would give me 9. Okay. That does it for Lesson 5 and finding equivalent fractions. If you have more questions, please come ask me. I'll be happy to help, and I will see you next time.